Okay, let's do this is part 2 of the video. It's very important to watch part 1 so that you understand. We are doing the problem. So here's the problem. It's 19.10. Yeah, from the same book. Notice I've added new problems also. They are interesting, especially 19.4. You must know how to differentiate the statement and the actual problem they ask you. 19.4 is very amazing. Yeah, so you need chapter 14 deflection to actually do that. The hint, if you know how to calculate deflection, you know you can calculate it. That's it. So it's just a mixture of chapter 14 and chapter 15 here. Yeah, other problems are hollow. Yeah, I'm still gonna add more problems, but I think on the description you're gonna get the full document. So in this case, you are not interested in other problems. Let's do 19.10, right? So we end up at 19.1. Let's do 19.10, right? Let's just do it on a new page. Oh, how already halfway. Hey, my page are running down. So, okay. So the problem here says calculate the Euro critical load. So they actually want P for the strands of T section. So we already know this, it's a T section. And then they say the flank width is being 10 centimeter. The overall depth is 8 centimeters, and both flanks and the stem are 1 centimeter thick. The strand is 3 meters long and is built in on both ends. So I, I don't know if you saw it. Let's do it step by step. So they ask us to find what? P. So PE, right? So we know that they said the strand is T section. That means the cross section is T shape, right? And they said the flank width is being 10 centimeters. Let's draw it perfectly now. So let me just use a black pen. So that means we have this thing, a T, like this. So it's just a T. Then they say the width. So the width of the flank. Where is the flank? So if this is a T, this is a flank. Always know that. Right? Remember the I section. When you have an I, we have a web here, and then you have a flank, and then a flank. Right? So a T is just remove one flank. So actually we have a web and a flank. So in this case, they said the web, the flank is about 10 centimeter. So it's 10 centimeter width. So from here to here, they say it's width. The overall depth. So from here, overall means from the topmost to the bottommost. So from here to here, it's 8 centimeter. They said it. Both flanks and long flank. Why they say both flanks now? Okay. Or both flank and the stem of 1 meter thick. So a stem here is this one, obvious. This is a stem. You must be smart people. If you don't know what is a stem is, you already know that is a flank. That means whatever that is left is a stem. So they say the thickness. So the thickness here is 1 centimeter. So from here to here is 1 centimeter. So obvious. Board, they say board stem, board flank and stem are 1 centimeter. That means also here it's 1 centimeter. Right? So from here to here it's 7 centimeters. We know it, right? So already we're given E. So always take off notice of E. E is equal to what? 2 times 10 exponent 5. Right? What else we are given? So we are given L is equal to what? 3 meters. But in the question they said built in. That means both ends are fixed. So if we're gonna bend it, it's something like this. So imagine this. Let me draw it in 3D. So it's a T, remember, cross section, and then we bend it, bend it. So it's gonna be something like this. It's just for fun, people. So it's gonna bend here also. So it's something like that. So that's P, we are introducing force P, and then it's bent. Remember, when you are introducing force P, so this was initial. Oh, that's why I was saying E, because remember intrinsity from chapter 11, yeah, that's why I was saying E. Okay, it's fine. So this distance from here is E. We are not interested in that his theory, how the formula came about it. You can read about it if you like, especially in Dr. B.A. Bansal. So LE, both ends are fixed. We know that LE is equal to what? I forgot. Let me go and check my notes. So if both ends are fixed, L over 2. You should not forget L over 2. That means L effective is 3 over 2 here. Meters, you can convert it. What is 3 over 2? 1,5 meter, which is just equal to 500 millimeters. Just times by 1,000. Because I always work with millimeters. It's simple. So this is what the information we have. We already have E, and we are given Newton per millimeter. Don't be confused. That is a square. So Newton millimeter square, which is MPa. So we're gonna use millimeter. So we have 1, 2, right? L effective, remember from the question, right? So the formula PE is equal to pi squared EI over LE squared. So we have this, we have this, we have this. We need I. Yeah, we need I. So which I? So if our cross section is like this, let me write it with another crayon. So if our cross sectional is like this, so we have, let's just say this is IYY, and somewhere here, remember this is a T, XX. So which one? We don't know. It can be IYY, it can be IXX. Here we don't know, right? So we have to calculate them both always. Whether sometimes even if you know which one, just calculate them both, right? For marks, you are not in the industry here. You are not saving time, you are saving life. Obvious. Most of the time, you must always calculate, double check before you say go ahead. So let me redraw the structure. So I've redrawn the structure. Let's call this 1, call this 2, right? So the first thing, we need to find the centroid, always, right? Depend on the reference we like, right? Obvious, let's just do step by step. Let's focus on what we want to find IXX. Let's start here, right? So the process is the same with IYY. So in this case, the first thing we have to find is the centroid. We need to know where is the position of this thing. If you know, it's easy. If you don't, in this case, we don't know. Then after that, you can use the table method to find IXX. That's it. So let's start. So for a centroid, we know, let's just draw IXX only. So IXX is somewhere here, right? Then obvious for the centroid, always remember reference. So let's say this one, bottom is the reference every time for the centroid. So I'm showing you this because most people, if you're gonna check my previous video, you know how to calculate this thing by now. So let's focus. Let's calculate the centroid. So it's gonna be a part. So the formula is just what? Remember, in this case, we are dealing with vertical. So we are dealing with y. So y bar is equal to what? Sum of y, a over sum of a. This thing must be in your head. Right? Part. So we have part 1, which is dimension is 10 to 100. So don't be confused. 10, I just converted this into this. Yeah, 1 centimeter is 10 millimeters. 10 centimeters is 100 millimeters, and so on. So don't be confused. So the part 1, the area is what? 10 by 100. Then I always do step by step to avoid confusion. You can write it in one line, it's fine, as long as you know what you're doing. But I always take the longest way. So the area and then y bar. So what is my y bar for the first part? So from the reference always to here, so it's 75. Yeah, 75, because 70 plus half of this. Remember, the center of this one is here and this one is somewhere here. Then again, part 2 is this one, which is 10 by 70. So part 70 by 100, by 10, I mean. Yeah, by 10. Then the centroid from the reference to here, it's what? 70 over 2, which is 35. Then we have to calculate YA and then total. So area total. So I have calculated this thing. So the area 10 times, you just add this area. So 1000 plus 700, 1700. Then obvious, this times this is this times this is this. Then you add again in this. Remember, this is the sum of this is the sum of this. Then y bar from the bottom. So from here to our centroid of the area is what? 58,53 millimeters. So that is easy, people. We've been doing this. Then from there, it's easy now to find IYY. So remember, no, IXX, I mean, if you use the formula IXX bar plus area times Y bar, Y squared, I mean. And then again, table method, you're gonna have a part. Okay, let's just do it. So again, we have 100 by 100. Then we need an area also, which is 10 by, which is 1000 basically. Then we have, what else do we need? IXX bar. So what is the IX bar of this one? It's easy, people. There's no references, you just need an IXX bar. So which one do we cube? So obviously we're gonna cube the length. Remember, we always cube. If this one is vertical, whatever you want, we always cube the one that is horizontal. Okay, this thing is horizontal, we're gonna cube vertical, vice versa. So let's do it. So it's gonna be, it's a rectangle, so it's gonna be 10 cube times 100 over 12. Then what else? We need y bar squared. And we know from previously, it's just y of this one, of the part, minus this y. So this can y total, all squared. Always, it's always like this. Y of the part, y total. I want you to get into the habit of saying y of the part, y total. Because we're going to go into chapter... which this chapter? I think it's section but just always y part of this all squared. So in this case, it's gonna be what? 75 minus 58,53 squared. Then again the same thing. Let me just pause and just do it. Yeah, same thing for another part. So this is for another part. This is 35 minus, so 35 minus this, always, yeah, always remember we cube the long, remember this one is horizontal, we cube the vertical one like this. Then yeah, let's go and find the answer. So I've can't, then you use this formula, take note of the formula. So we have this one, so this one plus this times this, then we get this answer. Again, take note of the formula. So area, this times this plus this, don't be confused please, and this is the answer. Then the total answer when you add, so ixx for this part, the whole part, or t if you like, is just equal to, yo, what happened, yo. So now, so we have 952,990,196 millimeter 4. So we have something like this, millimeter 4. This is our ixx. So the ixx of this one is this one. Remember, we don't know, we need the least one. Meaning what? We need to calculate iy. Let me redraw the structure. Remember, this is education, so in exam you can just do it in one way. I'm just showing you both ways. Take it step by step because it's a lesson, but you use your own method if you know the easiest one. I'm just showing you the technical way. So let's do IYY now. Okay, for IYY again, what is that falling? Okay, the mouse is fine. For IY again, same procedure. We want IYY, so we need a centroid. Then we can calculate IYY. So it's that, right? Then how to calculate a centroid? This one is easy, but again, x bar is equal to xa over ea, right? But this one is easy, straightforward. Why? Because it's symmetrical. So this one is just symmetrical. So there's no need to calculate it. It's just a proof. We will actually do it. We already know it. Then IYY, what is IYY? Then again, let's do it. IYY is just equal to IYY bar plus, so x, let's start x squared. So notice the formula, but here is this one. Why? For a composite, remember, for a composite we use this formula, each part, and then we add the total. We add individually. So let's do it. I already know. Let's say the reference is this one. Let's say the reference is the endmost. Some people will say the reference here, it's fine. So if the reference is here, yeah, let's make it here, right? If the reference here, then from distance to the centroid is what? It's 50 millimeters, right? But if it was here, if the reference was here, remember we are dealing with x now, x, y, x. If the reference were from here to the yy, but if the reference was here, it will be 0. You must take note of those, right? The reason why I take the reference here, I'm avoiding negative, please. That's why. But you can still take this one, the mid one. It's gonna be easy. Yeah, you can take the mid one Yeah, it's much easier and much faster when you take this one, right? Yeah, you just take these references. So it means what? Our x bar is 0 if the reference is here. Then yeah, everything is easy in this one. Yeah, it's easy. But let's just do it them both. So you see this one is easy, but let's do it this one the long way. Right? Because sometimes we always waste time in the exam. That's why it's very important to practice. Must always choose this one. It's easy. 40, you do this one. Let me just do the easiest one. So in this case, let's say the reference is here, right? That means x bar is symmetrical 0. That means our centroid x bar is 0. So the distance from 2yy is actually 0. And then now we know Iyy is equal to Iy bar plus ax squared, right? Let's just do it. Part, so we know it's gonna be what? The first one is 10 by 100. So 10 by 100 again. Then what is our area? 1000 again. What is my x bar? X bar is equal to x of a part minus x bar of the total. So we know this is the x bar of the total, but we didn't calculate the x bar of the total of a part. But we know the x bar of this one is 0 also. Why? Because the x of this is 0. You see, that's why I say this one is easy. Then remember squared. Then y bar. So y bar is horizontal. So for this part, top part, yeah, for this part, Iyy is like this. So we're gonna cube the horizontal. So it's gonna be 100 cube times 10 over 12. Then again, part 2, which is this one, 10 by 70. Again, the area is 700. Again, x bar is 0. Then Iyy is what? We're gonna cube what? So if Iyy is like this, we're gonna cube the one that is perpendicular to it, which is 10. 10 cube times 70. Yeah, over 12. Right? So we can see from the formula, then we calculate individual. So we know that there's no space to write. So for the first part, let's say for part 1 is equal to 100 cube times 10 over 12. Yeah, because when you substitute 0 here, everything is gonna be 0. Part 2, yeah, look into this plus look in this, you can see. Then I total, so Iyy in this case is just equal to, you just add this thing. So it's gonna be 100 cube times 10 over 12 plus 10 cube over 70 over 12. Let me just calculate it first. So the answer here is what? 83916.67 millimeter 4. So you see, this one is easy. The reference is in your midpoint, symmetrical. The answer was fast. But you can still use this one. You can use this reference and then say 50, x bar is 50. You do it if you like. Because not all the time will be like this. Right? So imagine if it was like this. So you see, the best reference would be this one. And then from here to here, from here to here, it will be easier. So practice them both. You're gonna get the same answer. Just follow the same method. So which one is the smallest? So we have this one 8. How many figures? 1 2 3 4 5. And this one 1 2, same number of units. So obvious 95 is bigger than 83. So the least one is what? So this is the least one. So this structure, so where is that question? So this T structure, this T structure is gonna bend by IYY. So it's gonna bend with IYY. So it's gonna bend, if it was a roller, if it was like this, and then IYY is gonna bend like this. So that's what it means. This is the least. If this one IX was the least one, it was gonna bend. Obvious, it's gonna bend like this. You see, it's difficult to bend because it's not the least one, it's the long one. So yeah, so it's gonna bend by IYY. Yeah, obviously a roller is not a T junction. So let's continue. Let's substitute and see if we find this answer. So now we have this one. Then it's the method of substitution, people. So let me just pause and substitute. So I've substituted. We are given from the question, remember, here is it. And then we use the least one, which is this, and then this. So the answer is this one. So yeah, it's the same. Yeah. So this one, notice kilo, this is one. Yeah. So the answer is what? 76,9 kilonewtons, if you like, or just write it the whole and say Newton, right? Unless the question states as what, right? So this is the P we are asked, right? So you now know. So you must pay attention. So already know the reference. You practice this and see if you get the same answer. Yeah. So basically, yeah, this table method helps. So this is a table. This is a table. Just draw the lines. You can see it's a table. Yeah. Yeah. Basically, that is Euler. So again, up to you. I'm gonna leave this thing in the description as I did in the previous video. Petris, people, Petris, just more questions. 19.4 is interesting. All of these are interesting. It's just to work with your mind. There's another question here. You're gonna don't think too much. I still have to do it and find which one is the wrong one. I think I don't know which one, but just know there's one wrong. So I'll tell you which one. Thank you. Just pictures. Yeah. Thank you. Thank you for the support.